Good evening, everyone. A very warm welcome to our hands on workshop on artificial intelligence and machine learning in bioinformatics. My name is Anusha, and I'll be your moderator for the sessions. We are excited to have you with us for this comprehensive workshop designed to cover the fundamentals of Python, machine learning, biostatistics, and image processing. It is my pleasure to introduce our speaker, Dr. Preenan Bakchi, an esteemed expert in the field of bioinformatics and currently serving as researcher, who is also the founder, director of Buses Genomics Research Lab, Bengaluru. He has completed his postdoctoral research from University of Lorraine, France, in Science Engineering Research Board, Government of India. He has also worked as assistant professor at Padma Shri Group of Institutions, Bengaluru, and MGM University, Chhatrapati Sambhajinagar. Sir has earned his doctorate from Career Point University, Kota, Rajasthan, India, 2016. He holds certification in Ayurveda, Yoga, and Sanskrit. During his doctoral research, he had attended IBRO-sponsored Advanced School of Neuroscience at Monash University, Malaysia. He has authored over 50 research and review papers in several national and international journals and in conference proceedings. He has presented his research works in conferences abroad. Sir has also guided several graduate and postgraduate students. He is an editorial board member of International Journal of Public Mental Health and Neurosciences, International Journal of Psychosocial and Cultural Genomics, Consciousness and Health Research, and Neuroscience Research Letters. Very good evening, sir. Over to you, sir.
Yeah. Hello. Hi. Good evening. Am I audible to all?
Yes, sir.
Okay, great. Thank you so much, and thank you so much, Anusha, for the introduction. Anusha, can you please enable the screen sharing?
Yes, sir. 1 minute. Sir, you're able to share screen?
Yes, yes. Okay. I think my screen is visible to all.
Yes,
Full
sir.
screen. Anusha?
Yes, sir, it is visible.
Is my screen visible to all, the full screen?
Yes, sir.
Okay, great. Okay, so good evening, everybody. So let us begin this wonderful journey of machine learning and AI. So before I start, I wanted to tell you regarding this machine learning. So this term will be quite familiar, and maybe the term is like quite fascinating. But anybody might have wondered what may be this term actual meaning. So the actual meaning of this term is like how we teach or tame a machine for communication. Mainly, like we humans communicate with machines. So we give the machine a particular language. Usually, it is in the binary digit of zeros and one. That is what the machine understands, and the manner which we communicate with the machine is the simple language is machine learning. So in short, machine language is the language which humans use to communicate with any machine. And currently now most of the machines are connected with the computer. So it is like we are actually using the programming languages for communicating with the machines. Okay. Okay, so as I gave the simple definition, now the broader definition is given here. The machine learning is a programming to computers to optimize the performance criteria using example data or past experience. That is the actually what we are doing it. So based on if we are giving the computer or training the computer to perform a particular task, then the machine will be understanding or reading our task, and then automatically the particular machine will be doing the task what we desire. Okay, that is the basics of the machine learning. It is very simple. Like if you remember, you might be getting training for something. Example like in the childhood days you might have undergone some training program like say for example cricket. So first your trainer will be training you how to perform in, and slowly you will be getting accustomed to learn or how to play the cricket. So after sometimes maybe after 1 month or 2 months you will gain the experience, or you will gain the knowledge rather to play the cricket. So in the similar manner, in a particular machine, we first train the machine with some particular task, and on the later stages, the particular machine will perform the task which it is learning and which is based on our commands. Okay, so there is no need to learn to calculate the payroll. So learning is used when human expertise does not exist like navigating on the Mars. Humans are unable to explain their expertise, speech recognition, solution changes in time routing on a computer network, and solution needs to be adapted to particular cases, that is user biometrics. So what we talk about when we talk about learning, so learning is very simple. Like in the classes, you are learning what the teacher says you. That is the simple about learning. So you might be remembering that you might have first gone in the class of nursery, then KG, and class one, and then finally slowly two, three, four, then 10th you have completed. Then plus
Read, Papa.
I request the participants to mute your microphone. Sir will be joining in 2 minutes.
Yeah, sorry, I got disconnected. Okay. So as I was talking that, suppose you are like after fifth standard, you are studying in a particular class from nursery, then KG, then 1, 10, 2, then class fifth. Suddenly your parents are getting transferred. Then you are moving to a complete new location. Then the particular if you are going to the in a new school, the school will ask the transfer certificate. So what exactly is that? The school also will need to know that you have already passed the class fifth and you need to go to the class sixth. So it is not that the school deliberately needs the particular thing. It is that it is a gradual step. So each and every step, it is like based on your age and based on your learning, you are learning it. So that is called as the gradual step of learning. So learning general models from a data of a particular example. So data is cheap and abundant. Yes, everybody knows that data is very cheap. Rather, maximum of the data are freely available, and it is abundant. There are several websites or there are several sites where the data are actually dumped, and you can directly retrieve the data from the particular archive and you can use it. Then, and there are a few examples it is given, like customer transactions, like people who brought Da Vinci Code also brought five people you meet in heaven, etc. Build a model that is a good and useful approximation to the data. Okay. So data mining. So anybody might have wondered what is this data mining? Why the word term mining is coming into picture? Mining is simply the simple word that is used in our normal language. That is mining. That is extraction. The simple thing is data mining. Means data extraction. In retail, it is used like market basket analysis, customer relationship management. In finance, it is like credit scoring, fraud detections, manufacturing optimization, troubleshooting, etc. Medicine, that is used in like medical diagnosis, telecommunication, that is quality of service and optimization. In bioinformatics, it can be used in motives, alignment, and so many other areas. In web mining, you have several search engines. So you might have very simple is like web mining is our Google. So if you just type in Google what exactly you need, you'll get lots of information. That is called as simple is the Google is giving you what you need, and the Google is the best thing for the data mining. Okay, before I forget, uh, if you are having any doubts or any queries, you can leave in the chat box. I will take the queries once and when I am just stopping in somewhere. Okay, you can just post your queries in the chat box. Okay, Anusha, I think now I am audible, right? I
Yes,
just
sir,
got
you're
disconnected.
audible.
Yeah.
Yes, sir, yes, sir.
Okay. In machine learning, we optimize the performance criteria using an example data or past experience. And the role of statistics. Actually, statistics plays a major role in machine learning. Though if you might have be thinking that I don't need statistics, so I am very weak in statistics and I cannot go ahead with the machine learning. It is nothing like that. Actually, it is very simple. Statistics is very simple, and the statistics, the broad name for the statistics is your data science, and finally it is the machine learning. In machine learning, maximum operations are your statistical analysis. And the role of computer science, that is efficient algorithms to solve the optimization problem and representing and evaluating the models for the inference. So some of the applications of your machine learning are associations. In supervised learning, you have classification regressions. Then you have unsupervised learning and reinforcement learning. We'll take this all the things one by one and with a proper example for you to understand. So learning associations, like in a basket association, you might get a probability like P/Y/X, where the probability that somebody who buys X also buys Y, where X and Y are the products and services. Very simple example in your Amazon is, suppose you are purchasing a books on machine learning by XYZ author. After you purchase that, Amazon will give you a suggestion that this particular people, after purchasing this particular product or this particular book, have also purchased this. That is called as a learning association. So how Amazon will tell you? Based on the past experience. Amazon is programmed for that. So that is, even if you are typing in Google, like if you just type in instead association, just like AWS or CI, then it will give the suggestions. Is it association or is it associate or something like that? So that is based on the probability of like searching. So this is a very simple example of your association. Then classification in which similar items are classified in a single group. Example, credit scoring. You might have heard about in credit card, there is something called as CIBIL score. So CIBIL score is something that they have classified based on the several parameters, and the particular customer, say for example, the CIBIL score, say for example, it is 700 or less, they will tell that you are not eligible for any kind of loans or any particular offerings. So that is, they based on your performance, based on your CIBIL score, they will give the analysis. So that is one type of classification. So differentiating between the low risk and high risk customers from their income and savings. Applications, you have pattern recognition, face recognition, that is pose, lighting, occlusion, that is glasses, beard, makeup, hairstyle, etc. Character recognition, handwriting speeds. Speech recognition, temporal deficiency, use of a dictionary or syntactic language. And in sensor fusion, combine multiple modalities, example, visual, lip image, acoustic speech, etc. And from in medical diagnosis, some symptoms to the illness. So very simple example. If you anybody from the participants, if they are in the staffs, they might be knowing that when they are going to the college, then there is a face biometric or thumb biometric. So if you are placing your thumb on the particular biometric or just showing your face, it will directly pull up your own picture. So, and that is one kind, that is directly it is picking you and it will give you everything. Now, suppose you want to know, so like how many persons have a particular resemblance like me. So in that manner, using the face recognitions, you can get it out. Example that when you are training a particular model for, say for example, cats. So you are giving the particular model model all the examples of cat facial expressions, facial images. Then on the output, after it is processing, you are giving the image of a dog. Immediately the system will say it is not a cat. So that is again a facial recognition example. Speech recognition, yes, when once you are speaking in front of any particular Google, you might have recalled that you are asking Google to search any particular thing, the Google will immediately recognize your speech. If you are speaking in English or Hindi or any other language, automatically Google will understand which language it is. Is it like English or Hindi or any particular language, and it will automatically translate, and it will show you what exactly you require. So these are the very simple examples for your classifications. Just now, as I told you, face recognition, that is training example of a particular person, and then you are giving the test images. So if once the training is done, the particular model will definitely recognize the particular test image. So first, anyway, the training will happen, and then automatically you can test the particular model that it is working nicely or not. So after building the model, you need to train it, and then you have to go ahead with the testing. And finally, you will come to an conclusion that how good is my model, or how good have I trained or designed my model. Okay, let me see if there is any questions. Okay, there is no question so far. Okay. Okay. In regression, every example, the price of a used car. Suppose you want to sell your used car, then you might be wondering what price may I keep for my car. Okay, so based on the regression analysis, that what regression algorithm will do, it will pull out from the databases all the prices of the cars, used cars of the same model, based on how many years it is purchased, and give you an answer. Okay, you can give the price of your car approximately in this particular range. So that is a very simple example for your regression. Okay, regression applications, navigating a car, angle of the steering wheel, that is CMU NavLab, and kinematics of a robot arm. So in this particular manner, you can go ahead with the regression analysis. So we will be seeing in the subsequent classes how you can use regression and how you can use classifications for developing your models. Next is supervised learning uses prediction of the future cases. So use of the rule to predict the output for the future input. A very common example can be, if at all you are using a particular medicine, you might be knowing that you are all using paracetamol for the fever. Why you are using it? You no need to go to the doctors for taking the paracetamol for the fever. You know it. How you know it? Or because it has a very in the past there are several examples that paracetamol is successfully used in treating the cases with fever. In a similar manner, suppose you want to use a particular medicine for any particular disease, example, lung cancer. So you might go to the history, pull out the history, and see to it that what are the medicines used for treating cancer, and what is the outcome. How successful is the particular medicine? And based on that, you can understand that, okay, this particular medicine I can safely use for cancer. Okay, these are the one classic example. The knowledge extraction, the rule is easy to understand. So if, suppose in history, whenever you want to draw some particular conclusion about any particular, say for example, fort. So based on the past examples of what kind of force this might be, what kind of curvatures, or what kind of design is this. Based on that, a particular archaeologist, they will definitely understand that to what extent, or to what what manner they can classify this particular fort. Then compression, the rule is simpler that the data it explains, and outlier detection, exceptions that are not covered by the rule, that is fraud detections. So suppose in the whenever you are getting a spam call, you might know that. So spam calls are coming in red. So very simple, your mobile uses this outlier detection to understand that this is a fraud call, or this is not a fraud call. Unsupervised learning. So learning, what normally happens, usually in unsupervised learning, you may not get any output, but based on that, you can come to certain conclusions. Clustering, grouping the similar instances together, and examples like customer segmentation in CRM, image compression, that is the color optimization, and in bioinformatics, we have learning motives. Next, you have reinforcement learning, that is learning a policy, a sequence of outputs. So based on a sequence of outputs, you can determine, or you can come to a conclusion what may be my policy for taking a new product. So in reinforcement learning is similar to both your supervised and unsupervised learning, in the manner that it has supervised learning algorithm, wherein first it will get trained based on the supervised learning, then it will give output, any unique output. So how that the output will come based on the sequence of outputs. So, reinforcement learning, it first takes your supervised learning in the picture, and then it gives a new different output. Okay, so in reinforcement learning, you may not get a supervised output, but a delayed reward. That is our very thing in the reinforcement learning. You may not get an output as per a supervised output, but you will get a reward. That is the main point in reinforcement learning. Then credit assessment problem. Then game playing, robot in a maze. You might have come across this robots in a maze, game playing, and so on. Then multiple agents, partial observability. Okay, some of the areas and of AI and some dependencies. So you can see there in AI, first it is like search. So it can be search related to logic or NLP. So search, so you have to come to a conclusion that where should I go? Then you then search for machine learning. It may lead to vision. Search for planning. It can lead to robotics. Then search with logic. It can go to expert systems and so on. Like in AI, you can implement so many machine learning problems for getting your outcome. So AI is an advanced version of your machine learning. So what exactly is your machine learning? Making computers that think like human beings. Or you might have come across the term that AI, artificial intelligence, that you are making the computer like human. Is it that computers are really thinking? Let us see. The automation of the activities we associated with the human thinking, like decision making, learning, etc. The art of creating machines that perform functions that require intelligence when performed by the people. the study of the mental faculties through the use of computational models. So what do you think based on all these particular questions? Actually, a machine learning algorithm can perform all the above tasks. And it is not that it will perform tasks, it will, like we think, or we are utilizing artificial intelligence to give us such kind of output. Anusha, please, somebody's video is on. Anusha, somebody's video is on. Just check it, take care. Even it is unmuted.
Yes, sir.
Yeah. So again, in artificial intelligence, the study of computations that make it possible to perceive, reason, or to act. These are all different areas, though they are all with the question marks. It is like they're all correct. Nothing is wrong. Though it is with the question mark, they're all correct about machine learning. A field of study that seeks to explain and enumerate intelligent behavior in terms of computational process. A branch of computer science that is concerned with automation of intelligent behavior. And anything in computer science that we don't yet know how to do properly. So anything, what you think can be in the AI. AI is like whatever you think, you can design a model or machine to do similar tasks. That is simple concept of your artificial intelligence. So what is again artificial intelligence? System that think like humans, system that think rationally, and what is coming very much is that system that act like humans, system that act rationally. Okay. Okay, system that act like humans, that is Turing test, the art of creating machines that performs functions that require intelligence when performed by the people. So art of creating machine, you might have always seen in the movies about the robots and what is a Transformers movie wherein a robot is mimicking a human being. So that is actually very far. If we just see in our own hands, we have our ChatGPT or even Google. Those are the very simple examples of your AI machines. Do you might be thinking that, sir, these are not machines, these are all softwares. Yes, that is also true. Because software, other name for the software is tools. So you are now able to, you are in a position to design tools of AI. And still there are research going on wherein people are actually developing or creating machines, which to some extent, I will not say exactly, to some extent it is resembling human being. The study of how to make computers do things at which at the moment people are better. Okay. You enter a room which has computer terminal, you have a fixed period of time to type what you want in the terminal and study the replies. At the other end of the line is either a human being or a computer system. Many of you might have given the online examinations. Maybe not for your academics, but for related academics. You might have seen that the system is getting on at a particular time, and your software will get switched off at a particular time. So systems are acting like humans. If you might have given the example for your NTA, there it will start at a particular time. That is, if it is 11:30, it will start at sharp 11:30. And it will, if it is ending at 1:30, it will end at sharp 1:30. So that is, systems are acting like human beings. In the normal academics, it is the teachers who will, after paper distribution, so from first roll number 1 to last roll number, there will be some time difference. Again, at the end, the teachers will be correcting your question, answer scripts. So it is like exactly that the time may not be followed. But if you at all you are giving a particular system, so immediately at the start time, saying let it, if it is like 11:30, the system will pop up that you are ready to answer the questions. And immediately once it is over, you will see the system will automatically, the screen will turn off. So you can say that yes, the systems are acting like human beings. If it is a computer system, at the end of the period, you cannot reliably determine whether it is a system or a human, that the system is deemed to be intelligent. Okay, the systems that act like human beings, the Turing test approach, a human questionnaire cannot tell if there is a computer or human answering his questions. If there is a computer or a human answering his questions, but is via teletype, the computer must behave intelligently, and intelligent behavior to achieve human level performance in all the cognitive tasks. Okay, the systems that act like human beings, these cognitive tasks include, that is, natural language processing for communication with the humans, knowledge representation to store information effectively and efficiently, automated reasoning to retrieve and answer questions using the stored information, and machine learning to adapt new circumstances. Let us see this one by one. So what is natural language processing? It is written there for communication with human beings. So you might have wondered that currently the complete world is connected with each other, even if you are not knowing the language. If at all you are typing a mail in English and you are sending it to a particular person, say for example, in which country shall I say, Italy, and the person may not be well versed in English, the Gmail will be automatically programmed that it will translate the English into Italian language. Even if you can translate your mail from English to Hindi, that option is also available. So natural language processing is that like you are giving you are making a particular system to be multilinguistic. So there can be communication between any human beings from any language background to any human being with a different language background. So you might be wondering, in the United Nations, or recently there was a G7 summit, all the leaders went and gathered together. So how do you think that they might have communicated? Is it English? There were many leaders who cannot even speak English. They are using this that speech translations. So everybody will be using the speech translation, and they will be understanding what the particular person on the stage will be speaking. A very classic example you might have seen in our own India in Independence Day, when our PM will be speaking in Hindi, and you might have seen there will be several foreigners sitting. Do you think the foreigners will be able to understand Hindi? Definitely not. You might have seen that they will be wearing some headphones on their ears. It is right headphone that it is used for translation of Hindi to their own particular language. Okay. Then you have knowledge representation, that is store information effectively and efficiently. Suppose you are getting a particular data, but along with the data, you will have some particular information that what is this data about and in what manner the data can be utilized. Then you have automated reasoning to retrieve and answer questions using the stored information. A very classical example for this is any chatbot. So whenever you're asking any question to a particular chatbot, the chatbot will immediately reply to you back with the correct with the expected answer, and it will solve your issues. And if it is unable to solve, it will tell that I am transferring you to a human agent who will help you out in answering your queries. Then machine learning to adapt to the new circumstances. Then the total Turing test, it includes 2 or more issues, that is computer vision to perceive objects, that is seeing, and robotics to move objects, that is acting. So what is artificial intelligence again? That is based on the thought of human and thought rational, behavior of human and behavior of rational. The systems that think like humans, that can be called as cognitive modeling. Humans has observed from the inside. How do we know that how humans think? Introspection versus psychological experiment. Cognitive science, then you have the exciting new efforts to make computers think, machine with the minds in full and literal sense. That is why it is called as cognitive modeling, because cognitive modeling derives its term from the cognitive science or cognitive psychology, where it is based mainly on the thinking and behavior. So similarly, in AI, it is that we are doing cognitive process, hence it is cognitive modeling. The automation of activities that we associate with the human thinking, activities such as decision making, problem solving, learning, etc. Again, artificial intelligence, that is thought versus humans, and thought versus rational, and behavior versus humans, and behaviors versus rational. So system that think rationally, laws of thought. So humans are not always rational. So rational is well defined in terms of logic. Yes, definitely. Logic can't express everything. Example, uncertainty. And logical approach is often not feasible in terms of computation time. It needs guidance. So in this particular case, actually, so far, like machines are unable to give a proper logical or rational answers. So that is what the study of mental facilities through the use of computational models. So people are actually linking the computers with the brain to come across with the logical or rational thinking. Study of computations that make it possible to perceive, reason, and act. Finally, the system that act rationally, rational agent, that is rational behavior, doing the right thing that is, which is expected to maximize the goal achievement given the available information. Giving answer to the question is acting. And I don't care whether a system replicates human thought process, makes the same decisions as humans, and uses purely logical reasoning. A very classic examples for this is that you might be using games like Ludo or chess, wherein you are playing against the machine. So at that time, sometimes usually the particular system is programmed to win, because it is based on cognitive actions of various human beings. But if at all you are able to defeat that particular machine by playing Ludo or chess, then you are actually, then you can understand that your logical or your rational is far better than the system's one, and which the system is trying to capture. And as I told in the initial thing, that the machines are actually learning So once you are giving the logic of how you can defeat the particular machine, the machine will actually learn that technique. So that is again a rational thinking. Okay, systems that act rationally, logic that part of a rational agent, not all rationally. Sometimes logic cannot reason a correct conclusion. At that time, some specific in domain human knowledge or information is used. Thus, it covers more generally different situations of the problem. That is, it compensates the incorrectly reasoned conclusions. Okay, so what is artificial again? Produced by human art or effort rather than originally naturally. Intelligence and is able to is the ability to acquire knowledge and use it. So AI was defined as AI is a study of ideas that enable computers to be intelligent, and AI is a part of computer science concerned with the design of computer systems that exhibit human intelligence. From the above definitions, we can see that AI has the major role, that is study of intelligent part concerned with the humans and represent those actions using computers. And one more thing which is not here is that suppose you are in action with a particular intelligent agent, and the particular intelligent agent will actually learn from you when you are utilizing it. So that is again an AI. So don't think it is programmed, it is actually programming. Nobody can say that an AI agent or AI chatbot is programmed. It is, in fact, it is whenever you are also using it, it is, in fact, it is learning from you. So goals of AI to make computers more useful by letting them take over dangerous and tedious tasks from human, and to understand the principles of human intelligence. The foundation of AI, that is philosophy, at the time, study of human intelligence began with no formal expression and initiate the idea of mind as a machine and its internal operations. Mathematics formulates the three main areas of AI. As I told, you cannot easily leave mathematics for studying AI or machine learning, because it needs the logic and above all probability. So computational leads to the analysis of the problem that can be compared. Complex theory, probability contributes to the degree of belief to handle uncertainty, and AI. And decision theory combines probability theory and utility theory. So if you are thinking that if I don't have the knowledge of mathematics, how you can learn the AI, it is nothing very different. It is just that you need to know you need to have the basic understanding of the particular topic of mathematics. And because there are software, because AI or machine learning, there will be softwares to help you in calculating. You don't have to manually calculate. You just need to have a understanding what it is. Like if I ask you what is probability, you should be an answer to say that what is the probable outcome. That's all is needed. It is not that you need to calculate the probability of like how many times 6 is occurring in a die, or how many times tails is occurring when you are tossing a coin. Nothing like that. You don't need to actually go into the calculations. There are softwares to help you to do that. Just you need to understand what exactly is happening, and what can be the outcome or output. That's all you need to know from mathematics. Actually, in AI, if you need to learn, you know, not only probability, you need to even understand algebra, arithmetic, and almost everything of basic mathematics, what you might have learned in your 10th and 12th. Everything is needed. That is the foundations of your machine learning and AI. But as I told again, I am telling again that you don't need to learn all the formulas and all, just the basic understanding, and you can solve the complex problems of the AI. Okay, so psychology, so how humans think and act, the study of human reasoning and acting. It provides reasoning models for the AI. And so here you might be thinking why psychology is coming in the picture, that mainly AI and ML is a part of mainly for the computer science students. It is not like that. Actually, this particular AI and ML is beyond any particular subject. It is even the people from history use it, even the people from social science or psychology use it. So it is devoid or beyond any boundaries of any particular subject. No computer science person can tell that this AI and domain, since it is made by computer scientists, it is a part of computer scientists. No, nothing like that. Even so many in biotechnology, bioinformatics, psychology, even in sports, you might be seeing in the cricket, there are so many AI instruments or devices are used. So even in all the places, ML and AI is there, and it is like nobody can claim or tell a particular subject cannot tell that it is a part of only this particular. It is beyond or devoid of any particular subject. Even in psychology, textbooks are available where you can get machine learning for psychology. Such books are also available. Okay. Computer engineering, how to build an efficient computers, provides the artifact that AI applications is possible. The power of computer makes computations of large and difficult problems much more easily. AI has also contributed to its own work to computer science, including the time sharing, linked list type, data type, that is OOPS, etc. Control theory and cybernetics. How can artifacts operate under their own control? That is, the artifacts adjust their actions to better for the environment over time, based on an objective function and feedback from the environment, and not limited only to linear systems but also other problems as language, vision, planning, etc. Linguistics, for understanding the natural language, different approach has been adopted from the linguistic work. Formal languages, um, syncretic language and semantic analysis, knowledge representation. You might be seeing in your daily life there are conferences happening in the area of computational Sanskrit linguistics. It is one of the most, I will say, major advancing subject in India. That you might be thinking Sanskrit is an ancient language, but it has also taken computer science, and the subject has developed like computational Sanskrit linguistics. So you can actually do all the Sanskrit operations using computer science or machine learning. So just now, as I told, it is not even of any particular subject. You can see that it is taken even by the one of the ancient languages of India. So the way I told you this, in the particular area linguistics, Sanskrit is the key player, more than English. There are maximum research happening after, I will say, after English. It is in Sanskrit that you will be getting research papers in the area of computational Sanskrit linguistics. After linguistics, it is usually used for English. That you will get the maximum papers, research papers. Then Sanskrit linguistics. Okay. So the main topics in AI, artificial intelligence can be considered under a number of headings such as like search, which includes like game playing, representing the knowledge and reasoning with it, planning, learning, natural language processing, expert systems, interacting with the environment, that is vision, speech, recognition, robotics, etc. Some advantages of the AI: more powerful and more useful computers, new and improved interfaces, solving new problems, better handling of the information, relieves information overload and conversion of the information into knowledge. Disadvantages: it is like it increases the cost, difficulty with software development, slow or and expensive. Few experienced programmers, that is a very important thing in AI. You are the programmers, experienced programmers are actually less, and few practical products have reached in the market as yet. Search. Search is the fundamental technique of the AI. Possible answers, decisions, and courses of actions are structured into an abstract space, which we then search. Search is either blind or uninformed. Blind, we move through the space without worrying about what it is coming next, but recognizing the answer if we see it. Informed, we guess what is ahead and the use of information to decide where to look at the next. And we may want to search the first answer that satisfies our goal, or we may want to keep searching until we find the best answer. Okay. So knowledge representation and reasoning, it is the second most important concept in AI after the search. So if you are going at act rationally in our environment, then we must have some ways of describing the environment and drawing inferences from the representation. So first is search, then you have to have some knowledge about what is happening so that you can describe your own way that what is happening, what kind of data we are getting. So how do we describe what we know about the world? How do we describe it concisely? And how do we describe it so that we can get hold of the right piece of knowledge when we need it? A very common example, sometimes before I told, whenever you type in Google ASSOC, so you will be getting the term associate or association or something like that related. So you should know what are the terms. Like when it is like ASSOCIAT, you should understand that it is an associate with something. And then if it is an association, it is associated with what? So once the AI is that you are searching it, you should be able to understand what is happening. Then what search you are getting, then only you can get or you can catch the AI. Then how do we generate the new piece of knowledge? And how do we deal with the uncertain knowledge? So knowledge, it is like declarative and procedural. Declarative knowledge deals with facial questions, that what is the capital of India, etc. Procedural knowledge deals with how procedural knowledge can be embedded in the declarative knowledge. Next is planning. So first we've seen that searching, describing, and planning. Next. So planning, given a set of goals, construct the sequence of action that achieve these goals, often very large search space, but most parts of the world are independent of the most other parts. Suppose you are giving anything in the chat GPT example, just you give, but it may not give you in a sequential manner, or it may not give you in a manner how exactly you need it. So you can, once you are seeing the results, you can plan it and you can give to it a proper flow, that this can be the proper sequence. So that is the basic behind this planning. So often start with the goals and connect them with the actions. No, not necessary to a connection between the order of planning and the order of execution. What happens is the world changes as we execute the plan, or our actions don't produce the expected results. Then is learning. If a system is going to act truly appropriately, then it must be able to change its action in the light of experience. So how do we generate new facts from the old? How do we generate the new concepts? How do we learn to distinguish the different situations in the new environment? Next is like, then you need to interact with the environment. That is, in order to enable the intelligent behavior, we will have to interact with our environment. That is, properly intelligent system may be expected to accept sensory input, that is vision or sound, interact with the humans, that is, understand language, recognize the speech, generate text, speech, graphics, etc., and modify the environment. History of AI, you can actually, if I want to give this PPT, you can have a look actually. So the von Neumann architecture resembles much of our modern computers. Early period, it was like 1950s and 60s. That initially it was like game playing, then theorem proving on biological models. Symbolic applications in the use in the period of 70s. Commercial during the 80s. And then from 90s, you are using the new millennium. Then you are using the real world application modeling, better evidence, etc., etc. So you have so many things currently. Applications you have like visual recognition of the traffic, medical diagnosis, directory inquiries, power plant control, automated cars, and all. Fashions in AI. This all you can have a look. There are many things like during 1950s and 60s, how the machine language was there. It was like only zeros and ones and all. Okay. Then symbolic and sub-symbolic AIs. AI applications you might have seen. This is the first picture is of a rover. Then next one is of a satellite and so on. AI applications. That is all AI with IoTs. Then you have telescope scheduling. Then analysis of the data. Once you're getting the data, you need to analyze the data. Then image guided surgery. By seeing the images, you can understand where exactly to perform the diagnosis or surgery and so on. Then in transportation, autonomous vehicle control, you might have seen in a flight, sometimes you might have heard the term autopilot. There are some cars used in some countries wherein you don't need a driver for driving it. An artificial person will be driving the car. Even there are so many trains coming up in the market, like driverless trains. So it is all happening. So these are autonomous vehicle controls and so on. Pedestrian detection, the particular artificial human driving the car can even detect a particular person or pedestrian crossing the road. Games, that is anyway you are doing it. Robotic toys, it is there in the markets. Other applications like in bioinformatics, you have gene expression, data analysis, prediction of the protein structure, text classification, document searching, web mails, articles in news, etc., videos, images, music compositions. Just think a music person will also be using AI and ML. So you are not you are in the correct area. Natural language processing, perception, etc. And these are the several terms which you will be frequently using in this AI and ML, like correlation, cutoff score, data science, data scientist, decision rule, etc. Many are there actually. Okay, so I will be ending the class here for today. So if there is any questions, you can ask me now. Tomorrow I will start with introduction to Python, and we will be using the Google Colab to understand the Python. So any doubts, anybody, you can just put it in the chat box. Any person is having any doubt? Okay, and one more thing, just I wanted to share one thing. I received few feedback that some people want to prepone the class to 1 hour, that is from 6:30 to 7:30. So if all are okay with that, just type in the chat box. Okay, then from tomorrow I will be conducting the class at 6:30 if it is okay for all. If it is okay, please put in the chat box okay, and we will start by 6:30. If anybody is not okay or anybody wants that, say 7:30 is fine, we will continue with the regular time. So you can just put in the chat box. Seven 30 only you want? Okay. Any other person? So you want to continue by 7:30 only? Okay.
So I hope there are no questions from the participants. If you have any questions, you can unmute yourself. Okay, sir. Thank you so much for the insightful presentation on Introduction to Artificial Intelligence and Machine Learning. Thank you all the participants. So this concludes our session for today. We will reconvene tomorrow at the same time at 7:30. Please join us at the same time. Thank you, everyone.